Artificial intelligence can be kind of complicated to write on your own, and sometimes you just want something really simple. You just want an enemy to follow another object, and thankfully, GameMaker's kind of done that for us. In this example, I've got some sprites. I've got a wall. This is just to set up where the walls or the boundaries are in my room. And then I've got a player and an enemy, just the reverse color. And inside the room, just this one simple room, I've marked out where enemies and players can't go. Well, actually, the player can go there. And then I've also placed all these different enemies around the room and my player. And what they do, if I hop into one of these objects, is the player is very simple. I just click and then move around wherever the mouse is clicking, just so that we have something dynamic, something moving that the enemies can track. But the most important part of today's lesson is what the enemies are doing. And in this case, they're using something called motion planning. Now, there are three kinds of motion planning, and this video will just go over linear and potential. Linear is a very simple way of planning motion. It just looks from one point to another, and if anything's blocking it, it gets stopped. Straight line, linear, that's it. The first one I want to go over is MP linear step. Now we know what steps are. That's how many times the computer will cycle through our code. So this is going to happen every single time. It's always updating. And it's the linear version of motion planning. This will make an instance try to get to a position while checking for all other instances, but that's only if we say true. And I'll show you what I mean inside these arguments. First, we want to set an X and Y value. This is where we want the enemy to go to. We want it to go to a goal. Now I've set it up as goal X and goal Y. These are variables that are constantly being updated to where the player is. So it's always going to try to get to the goal, and that goal is the player's location. If we go back into here, step size is a variable that is speed. This is how many times or how many pixels it'll move towards that direction, towards its goal. I believe I've set that up as 4. So here we go, step size is 4. So every step, the enemy will move 4 pixels towards its goal if it can. That's the most important part, if it can get there. The last argument is check all. This is whether or not it should ignore all the other instances of objects in the room or whether it should treat them as boundaries, things it cannot pass through. I'm going to say true to this. I want the enemy to treat everything as if it's some sort of boundary. Now with just this one function, let's see what happens when I run the game. So as the room starts up, all of the enemies start moving toward me. They're drawing a straight line towards their goal, and then they just try to get there. And if anything, any object stands in its way, it stops. So these two guys started down here. Nothing was in their way. They just kept moving by 4 pixels until they got to me. Now, I'm another object in this room, so they stop when they get to me because we told them to. These guys and this guy got blocked by a wall. Once they're blocked by that wall, they stop moving. And that's it. It's just simple. It's linear. The cool thing is if I move around, they're still going to update. So once something is not in the way, they're going to try to go to me. Now this does not factor in line of sight. You've probably noticed that. As long as they have a straight line from themselves to me, they will move there until they can't move. Something is in the way. There's something that they will collide with. But they can still see through walls. So even though these guys down here can see me, they'll try to move even though there's a wall, see? So it's as if they're seeing through walls. You're going to have to write your own line of sight code if that's something you're looking to do. But I'm just showing you how motion planning works. Now, there's another function that's very similar to MP linear step, and it's MP linear step object. The only difference is this last argument. Rather than checking all instances or no instances, we actually get to define a particular object. So in this case, I'm going to define the wall. If you remember the last time I ran the game, they were bumping into each other. They would stop if another enemy was in the way. This time, I'm only going to check for walls. So now they'll be able to overlap each other, which is probably not something you want in your game. And we'll see it right here. There we go. They can also overlap me now. that doesn't look right. They no longer look physical. But this may be important if you need these enemies to collide with you and explode or do something in your game to cause damage or whatever your game is about. But they still get blocked by the wall because that is the object I defined. So these two functions for linear work exactly the same, but one will take all or no instances, and the other will choose just one object and then all of those instances of that one object. Now, another thing you can do is pathing. I've talked about paths before, and if you don't remember it or you haven't watched that video, you can go back and watch my video on paths. But in this case, with motion planning, I've got a variable called go. This just tells the enemy if he's allowed to move or not, so I'm not constantly starting a path over and over and over again. That's important to understand. Once again, watch the path video if you're not sure about this. This function is called MP linear path instead of step. So this function computes a straight line path for the instance. It'll draw a straight line from your object, whatever the calling object is, to a particular location. In this case, I'm choosing goal X and goal Y again, so that is the player's location in the room. It'll draw that straight line, and if it determines that there's nothing in the way, it can move there, it'll start a path. And that could be whatever path you want. In this case, I've already got a path defined. So this path is called path my path, and it's just a circle. That's all it does. It starts on the right side of the circle, and it just loops around it. So what will happen here is if the enemy is not already on a path, this will return true, so we can hop down here. The first argument of MP linear path is a path name. This is a path that will store the new path. It's kind of confusing. It just needs some path that already exists. My path actually already exists, because when enemies are created, I'm calling a script I wrote called path create. And in that script, if I middle click on it, I'm going to path add into something called my path. There's that variable. And I'm just going to add 2 points. The 2 points are me, my X and Y, to the goal X and Y, which is just the other guy. Or in this case, it's the corner. I set goal X and Y as the top right corner of the room. So that's what it's looking for. However, that will be updated every step right here. We're going to take the X and Y of the player and store it into the variable. So that's as the game's running after we're all created. Now if we look back at this, what it does is it needs some sort of path to store the information inside. Then it checks from your X and Y to the goal X and Y, whatever you're doing, the XG and YG. This is the step size again, how fast it'll be moving, and once again, whether or not it should check for collisions with all instances or no instances. This will return true or false. If there is a straight line with nothing in the way, it'll turn true. I'll come down here. We'll set go to false so it doesn't keep updating the path. It won't keep starting the path. And then we finally get to start our path. Seems like a lot of work, but that's the beauty of computers. It's a lot of work, and then it just goes. It does it really simple. This is where we actually get to start our path. The path we're starting is that circle I showed you inside of the actual path up here, my path. How fast it should be moving. What it should do when it gets to the end. I said stop when you get to the end of the circle. And whether or not it should be absolute. So if it's absolute true, that means it'll start wherever it physically is in the room, which means all the enemies will jump to this location and start going. But I said false. Start the circle from where you are. Kind of think of it as true, move the calling instance to the path. False, move the path to the calling instance. So, after that big confusing explanation, here's what it looks like when it actually runs inside of a game. Any of the enemies that can see me, which are only these two guys, because if you remember, right here, what they're going to do is draw a straight line, and if they can make it all the way to me, they'll start a path. These three guys cannot. What they did was they looked through this path move, 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 move at step size, which was the speed of 4. And then if they found a collision, they're like, okay, I found a collision. I'm returning false. Don't even bother starting the path. These two guys did see me. They had a straight line to me, and since it returned true, they start a path. And there they go. This 1 and 0 represent the variable go, whether they're allowed to move, 1, or shouldn't move, which is 0. Now, of course, this is not taking into account any kind of collision once they're on the path. That's it. Once they're on the path, they're going to indefinitely follow the path. You're going to have to write your own code for collisions while on a path when you do something with a path. But this is just to show you the differences between linear step and linear path. This one will just step towards the object. Even if it can't make it, it'll just keep going until it can't make it. This one will do it kind of in a loop. It'll look all the way through the path, and if it can definitely make it there, you get to start a path. Now, of course, we can do that same thing again, except this one is with an object. So instead of saying, hey, don't look through everything, or yes, look through everything, this one will take a specific object, and this one will just be the wall, and it should pretty much return the exact same thing. If there's a wall in the way, don't go, but if there's no wall in the way, start the path. Same thing, I just wrote it the same way, but it's to show you that there are differences to these functions if you need to do them. So that's linear. It's not very impressive. It just tries to move in a straight line, and if it can't make it, it stops. Either going as far as it can and stopping, or checking the entire distance and then starting a path. That doesn't really seem like AI. It seems really boring, which is why we can call upon something called motion planning potential. This is going to look a lot more confusing because it requires these 4 variables. You don't actually need to do this. This is if you want to change the settings. This is if you want to change the brain and how these objects are going to function once their instances are in the room. The settings for motion planning potential take 4 arguments: the maximum rotation, the rotations per step, the ahead, and the on spot. So let's just go through each one. Maximum rotation is the number of degrees to either side of the current direction that the instance can rotate in one step. Now the default is 30. That means that this instance can look 30 degrees to its left, 30 degrees to its right, and in that range, see if it can find a path to where it needs to go. If you decrease this, obviously it can't look very far and it'll have a harder time trying to make it to its destination. But if you increase it all the way to 180 so it can look all the way behind itself, both to the left and right, it's going to take much larger turns because it can take very large maximum rotation, and it might create more of an ugly path. So the default is 30. We can just keep it at 30. It's actually kind of okay at that number. The next one is how many rotations per step it can do. Right here, we've got the number of degrees to either side of the current direction that the instance can check for a collision. So this will look 10 degrees to its left, 10 degrees to its right, and see if there's a collision. And if not, it'll choose that path. Because right now what it's trying to do is make it to its final destination without colliding with anything, or whatever you're telling it not to collide with. Then we have ahead. This is kind of like steps or speed. This is the number of steps ahead that the instance can check for a collision. You have to remember the larger values are slower than the lower ones. So it'll look 3 pixels ahead of itself and see, is there a collision? No? Okay, I can go there. Now, if you set this to be a very large number, this takes a lot of computational power because that object's going to look really far ahead and calculate every single step along the way, and if it finds a collision anywhere along that entire path, it now has to check again by picking a different degree to rotate, checking ahead again. This is why it takes a lot of CPU power. But if you set it to a low number like 1 and only checks 1 space ahead, it will be kind of dumb looking because it'll move 1 pixel ahead, 1 pixel ahead, 1 pixel ahead. And then when it finds a collision, it's like, oh, I should have noticed that wall was there like 16 pixels ago. And now it'll have to rotate. So it waits until it gets 1 pixel away from a collision before it starts rotating to pick a new path. So that's the difference. If you want it to rotate really early, you set this to a large number because that's how far ahead it can look. It's kind of like its line of sight. How far ahead can it see? And if you want it to look kind of dumb, you set it to a low number. And then there's on spot, and this is what happens when it kind of gets to a location where it can't move. So we can use this to allow the instance to rotate on the spot when no path is found, which is true, or not, false. So what happens is, if there's no path available, it'll stop, and then we're saying, am I allowed to rotate to look for a new path, or do I just have to stop now? I failed, right? So if I say true, that means it stopped because there's something in the way, like a wall, and now I say, okay, you're allowed to keep spinning, keep rotating until you find a new path, which it may not, but at least we're giving it that option. But you may not want your object to do that. You could just say, no, don't rotate in spot, because if you think of certain objects like cars, when a car stops moving, it can't rotate without some sort of inertia, something to keep it moving. So with a car, you would say false. Stop moving, don't rotate on the spot. That'll look weird. That is a lot of information on the settings, and to be honest, you don't even need to use them. These are all of the defaults GameMaker will just give you without setting them yourself. But I wanted to let you know you can set them yourself if you need to. If for some reason your objects look stupid, make them smarter by looking ahead or giving them a little more room to wiggle with their rotation, or you can make them dumb or whatever you want. So we're just going to keep it at the default. Doesn't matter whether I have this on or off. And what you'll notice about the potential versus the linear is you get the exact same functions. You get step, step object, and path object. But now they're going to be intelligent. So let's see what it looks like by just writing this one line. MP potential step. So once again, we set the X and Y of its goal. Where does it want to go? How fast it'll move, how many pixels per step will it try to travel to get to that goal. Sometimes, by the way, you might want your step size and your look ahead to be the same. And whether or not it should check all objects, all instances. I'm going to say true, so it can't go through walls, can't go through the player, and it can't go through other enemies. And just with this one line of code, let's see how cool it is. So as you can see, the enemies are trying to make their way toward me. It's the same as with linear. They're just trying to find their way from where they are to where I am, but this time they're doing something intelligent. They're rotating their bodies to avoid oncoming collisions with any kind of obstacle. If there's a wall in the way, look, this guy's trying to rotate around it. Look at this. Look at them all trying to rotate. They're banging each other. Look, they're going around the wall, trying to find a new path toward me. Of course, this looks ridiculous, because usually in a game, if an enemy makes his way towards you, you lose health, instances are destroyed, the game is over, whatever happens in your game. Well, we can have this really nice merry-go-round system going on. But this is what they're trying to do. They're trying to make it inside me to my center point, and if they can't, they rotate and move again. That's what they're doing. Look at that. I wrote one line of code, and already I've got artificial intelligence that looks pretty decent. Now we can do the same thing again, just as with linear. We can do step object where we say, okay, only look for walls, don't worry about anything else in the room. So once again, they're going to overlap me, they're going to overlap themselves. There we go. They made it. They succeeded. And if I move somewhere else, they're going to try again. And you saw them kind of ridiculously rotate around themselves when I moved. Like that. They just rotated because of, the rotations per step and the maximum rotation before they can move. And we can do the same thing again with paths. So a straight line will be drawn from the object in question to the goal, and this is my player's X and Y. And if it does that, we're going to follow a different path this time. Instead of going around in a circle, we could. It'd be important to see what that looks like. If I type that I want to see my path, so this is if they can find a way to get to me, start the path as before, right? Look at that. They're doing that circle. But instead of stopping, they're going to keep doing it, because every time they get to the end of the path, they're like, okay, can I get to him? Well, yeah, because even though this guy can't get to me like 99% of the time, he could make it to this wall, rotate around it, and then come toward me, just like we've seen in the past. So with linear, only these two guys could follow a path. But with potential, everyone has the potential to get to me. They just have to avoid obstacles. Now, that's stupid. They're never going to find me, and that's not something you'd want with AI. You could just tell them to rotate yourself. However, this time we're going to do my path. My path is the one that is a dynamically generated path that starts at the center of my enemy, which is the calling object or instance, and it's always going to try to get to me. Same thing as before, except watch this. they'll actually wait until they get to where they were trying to go before they try to go again. So if I stop right at the end of this wall and now go somewhere else, they all wait till they get to that one point, and now they try to get to me again. So the difference here is that this one, they're constantly updating, or at least based on their look ahead and their rotation, constantly updating how to get to their goal. But with a path, they wait until they get to the end of the path. They wait till they go, okay, that was the last place I saw him. They'll go there, then they'll run through this again. They'll say, can I make it to him in a straight line? Yes. Start my path, which is go to him in a straight line. Of course, this is a little smarter. It's got potential. It can avoid obstacles. Then when it gets to the end of the path, it tries to find me again. So it depends on how you want to do it. Do you want them to, every step of the way, try to find their goal, or wait till they get to the end of a path? And of course, you can do this again with a specific object instead of all or none. Just depends on which game you're making and how you want your AI to function. But that's it. Those are two great ways, very simple ways, to implement some AI into your game. Give it some life without really spending a lot of time writing AI. Perfect, obviously, for top-down games, but you might find other ways to use it. So, if you want your enemies or whatever is using AI to just go in a straight line, use linear. If you want them to find some sort of way to get around obstacles, use potential. And with that, you now know the basics of motion planning.